Hey, what's good, y'all? Link here. I just finished the daily LeetCode question for today, and I did that pretty quickly. So I was like, why not try another one and do an extra problem? This one is from the weekly contest, 454. So let's see how this one goes. Let me do an extra, oops, extra 3583. Special triplets. Let's see. You're given an integer array nums, okay. Special triplet is defined as a triplet of indices ijk such that they are in order. Num of length, okay. Num index I is equal to num index j times 2, and then num index k is b equal to, okay, so they're pretty much double. Oh, wait. Return the number of special triplets in the array. Oh, wait, what? Num index I has to be equal to num index I has to be equal to num index j times 2. Oh, it's the next element times 2. Okay. This one. Oh, I see. I see. Okay, so this quickly like n is equal to the like nums. Mod is equal to and ninth plus 7. Okay, let's see this one. So times 2. Oh, so we only have, oh, we have this, and this, right? 0 times 2 is 0, 0 times, and then 0 times 2 is equal to 0. 0, 1, 2, and 3. Okay. You have a lot of cases. Okay. Hmm. Okay. I think we can. Uh, let's see. Let's see. I think how I want to attack this problem. I mean, the easiest way, but definitely won't pass this one, is just generate all the possible triplets and then checking if they match the constraint right here. Uh, I mean, it's a triplet, right? No, it's a okay. Yeah. Let's see. Hmm. This one's a good one to look at. Um, you know what? I can't. Mm, it's- okay, so let's say I choose 8 for the first element. So it will be kind of like for every I, we're gonna try every. Oh, it has to be in order, right? I is yeah, okay. So let's say for every I, we can choose j minus one element, and then for every j, we can choose j minus one element, right? So for every I, we can choose j minus one element, and for every j, we can choose. Wait, yeah, and for every okay, so for every I, we can choose I minus one possibilities for j, and for every j, we can have j minus one possibilities for k, right? So that would be like n cubed, which definitely won't pass this one. So what we can do here actually is, so if we can do in n cubed, we could probably do in squared. So we can fix I. Let's see. What if we fix I and then let's see. Fix I. In this case, is that an answer with 8? Okay, we do. Okay, so, okay. Let's say we fix I at 8. Fix I here. And then we have those options for J. Mm, oh, yeah, we have like a defined answer for each I we choose, right? Because if we choose 8, then we need to have a 4. And then if we choose 4, then we must have an 8 again, right? Oh, I see now. Yeah, because like if let's say this is A, this is B, and this is C, right? So A has to be equal to 2 times B, and then C must be equal to 2 times 2 times B. Oh, it has to be equal, right? Huh. Okay. So we have to find three numbers A, B, C, where A is equal to C and B has to be equal to E, and A is equal to C, and then B times 2 is equal to C over A. Okay. Okay. Let's see. So let's say we fixed our answer our I at 8. Mm, we must have another 8, right? Oh, can we use a two-pointer approach here? I think we can, right? And then we must count the what? The 4. So we only have one for this. Hmm. Okay, so um so we basically want to start the two pointers at the same element and then check the count of that element divided by 2 in this range. Okay, so what we can do here is so I need to know if we have like a dictionary to count the frequencies. I could actually do that, but I need the dictionary to give me the count for for a specific range. I don't want the whole thing, right? Let's see. And then we also have to be careful with the range because let's say we have like A, 8, and then 4. If we just count the absolute frequency, we may start like here, and then here we got the frequency. We saw that we have a 4, and then we had 1, but this is not a valid triplet. Um, okay. See how we're gonna do this one. Um, mm, let's see. We want the frequency count within a range. We want the frequency count within a range. Mm, we can definitely do a single for loop, and then for each element, I don't know about that one. Hmm. Oh my gosh, dude. Okay. Uh, I think no, I need a frequency count within a range. I don't, we're gonna use like a lot of space. Oh wait, actually, oh, I remember there was a way to do like, what's the constraint? What are the constraint? Okay, oh, constraint, okay. Um, okay, so I remember there was a thing like, in this case, hmm, I would have to return the count of, yeah, the total number of special triplets in the array. Okay, oof, I kind of don't know how to approach this problem. I mean, I know that we have to, let's say, let's try loop over, do like one for loop with the I, and then, I mean, you would have to use like n square space if you want to get like all the frequency count for each range. Hmm, let's see. Oh, actually, no. Nah, nah, no, yeah, we kind of would. What we can do is like, I want to set, can kind of like have a count, a dictionary that counts the index, that maps the index. Wait, no, I hate this one. 'Cause I want, if we want to get like a dictionary frequency count for each index, we would have to like an index that maps right to a dictionary, and the dictionary maps the element to the count, for example. Maybe not. Okay, let's see how the approach that I can take here. Hmm. Let me try to whiteboard this thing real quick. Let me open the whiteboard. Just 1 second. Okay, let's see. We're here. Let's try let's try this one, right? Okay, how would I approach here? Uh we could have, okay, use this arrow. Okay. Okay, we could have a pointer starting right here, and then we remove this pointer, but then the idea was like for each I need to go back from the right side. Oh, you know what? I grab the first eight check the number of twos. Yeah, and then count the number of twos, right? In this case, not the number of fours actually. But then, as I said, we would have to have a frequency count within this range from 0 to 3. It's not good. Uh, hmm, see. Uh, so if we start at 8, we would have to go over here, count number 4. Then we're gonna go here for 4, start all the way to the right again. But in the worst case, we would have to, this would be like n cubed anyway, right? Because we're gonna reach here, and then we're gonna count the numbers in here. So that's gonna be n cubed. Uh, let's see. So what I want here, I want to grab for each element, I want to grab the matching element in the rightmost position of the array, and then within those two indexes, I want to count the number of the element divided by 2. That's what I want. A count. Um, if oof, oh my gosh, dude. What about because what if we do hold an n squared array of counts? Mm, mm. Okay, let's see. Let's see. So let's say I have an array, a dictionary that will map the index, the index. Huh, this is gonna be n cubed. Oh my God, dude. If we map the index to a dictionary, they're gonna be n cubed as well. Oh my gosh, let's see. Let's try. Let's see a couple techniques that comes to my mind. Mm, two pointer doesn't work. I don't think so. I mean, the 2 pointer will be n cube anyway. Um, a frequency count within a range also won't work. Oof. Let's see. Oh, what if? Wait a second. Okay. What if I start at each index, we move outwards? So in this case, oh, we don't want to start with I. We want to so in I less than J less than K. I was thinking about looping using I, but we can actually use J, right? So in this case, we go 8. Let's say if 8 can be a possible candidate for the J, cannot, because we don't have anything on the right, on the left. So bam, go to 4. Starting from 4, we'll go outwards. we count the number of eights on the left side. Oh, we count the number of eights on the left side. We count the number of eights on the right side, and then let's see, we have 1, 8. What's the answer for 8, 4, 8, 8? So we have this triplet right here. This is valid. And then we also have this one with this one. I have 2. What if we have 8, 4, oops, 8, 8, 4, 8, 8? We're gonna have this, we have this, and then we have, let me, okay. So we have this, we have this with this, we have this, 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 we have this. Wait, let me count again. Okay, so this is 1, then we have 2, and then we have, actually, let's do, we have 1, we have, actually, oh my gosh, I need to make this smaller. There you go. Okay, let's see how many. If this is, so we have 2 on the left side too. This is 4, then we good. So 1, 2, 3, 4. Did I use this with this? I have this already. I did. I did. Wait. Let me count again. Oh my God. Let me do actually some lines here. Okay, so let's divide this. Let me do like an actual drawing right here. Oops. Okay. Okay, so we have 8, 8. Oh my gosh. Why is it so small? There you go. Okay, we have 8, 8, 8, 4, 8, 8. Okay. Let me kind of like give some split. Oh my gosh. Lines, put it right here. And paste the lines. Okay, this is good. And then we need some horizontal line as well. Let's make it super small. Okay, let's see. Well, let's say, first of all, 1, right? Then we can have the inside. Okay, now we can have this, this, this. And with the second one, we can have this, this, and this. What else? This. Can't have anything marked right here. We have to have this one marked. We can have either this or this, right? So this, okay, that's it. Yeah, it's 4. I guess so, yeah, I think it's 4. So it's the count of 8 on the right side, count on the right side, and then, so this is 2, 2, and then we do 2 times 2. Okay, I think that's right. Uh, let's see if that works. Result 0 for j in range of nums. So left count is equal to 0, right count is equal to 0. Then, okay, for I, okay, so for I in range of j -1, -1, if nums index I is equal to nums index j divided by 2. Okay, so this case, I have to be careful right here. So if nums index I, can we have odd numbers? We do, right? Okay, 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 okay. So mod 2 is equal to 0, and if we have an oh yeah, yes, right. It's actually times 2. Wow. I mean, if it's times 2, we don't need to do this because I thought it was divided by 2. Okay, so if I is equal to nums index j times 2, left counter plus equals 1, and then we do the same thing with the right. So k on j, starting from j all the way to n, if k nums index times 2, right count plus equals 1, and then at the end we do res plus equals left counter times right counter, and then at the end we just return res mod mod oops mod. Let's see if it's my work. I'm not sure. Let's see. Oof. Okay. Okay. What? How did I get 10? Oh, we have 0. Oh no. Okay, so I have here. Doesn't have anything here. Oh, I have here. Wait. 0 times 2 is equal. It's not. Wait, we need. Oh, we need 2 here. So let's see. Actually, do a quick log here. So let's see. Uh, okay, so let's do the index j and then left count, right count. Let's see. Wait. Oops. Wait. Not printing? Oh, I don't have to print. There you go. Oh, yeah, print. Okay, so at j is equal to 0. What? J is equal to 0. J is equal to 0. Oh my God. We don't want to start at the element j, right? We want to start at the left and start at the right. So -1 plus 1. Okay. Okay, let's see. Get rid of the print statement. Let's see. Do a quick submit. Please don't time out. Come on. My timeout here. Yeah. Oh, wait. I mean, I was doing for each J, we move to the left and then we move to the right. That's n squared. Is that right? So we want a linear approach? Oh, oh, time limit exceeded. Okay, maybe doesn't matter. Yeah, that's it. So let's say we got to four. You know what? Maybe we can cache this. Because let's say we have like eight. Oops, let me get this. Let's say we have like a four here, right? Mm, mm, maybe we can cache I and then j, which is the range. Hmm, nah. I was not expected to get a time limit right here. Uh, hmm, I mean, it is n squared, and the question, what's it? A linear solution. How can I turn this into linear? How can I get this information all of one time? I would use more space. I mean, is the index mapping to a dictionary of elements, right? I mean, I would use more space. Is that a way I can create this count? Oh man, let's see. Oh wait, nah. Yeah, the thing that I'm worried about is like, okay, in this case, we would just multiply by two when we reach the next four. But let's say the four was right here, right? Then that would be one, two, three options, right? It's not four options. We don't multiply by two in this case. Oof. I, uh, I might try the. Oh, I'm gonna use so much space, dude. If I do the dictionary, if I map, starting at the index, can't believe this gave me a time limit, dude. Yes, a lot of stuff. Mm. How can I map this in all of one? Okay, let's see. So I'm counting from the left, counting to the right, and then times. Hmm. Oh, I got time exceed on the last one? Oh no, never mind. Okay. Oh my gosh, dude. Fine. Mm. I feel like a small detail, a small change I can make here, it will give me like a totally different time complex. Uh, maybe. No, never mind. Oh no, let's see. Okay, 36 minutes in already. Okay. I don't want to use the extra space, right? Like, mm, I mean, I might have to. Oh man. Okay. How can I make this? Although I feel like I'm so close, but so we start in the middle and we have to count. Starting from four, we go outwards and check out the counts. Mm. I mean, I don't think it's gonna make any difference, but I could have the pointer and then move those at the same time, but I don't think that's gonna make any difference. Oh. So you want a linear. Maybe I'll look at the hints. Okay. Use the frequency area maps. Frequency prep and frequency next to track how many times each value appears before and after. Oh, so you do want me to use the extra space? Oh my gosh. Okay. It's mm. But that one, do we make like a dry run and populate this? Use frequency arrays or maps. Frequency prep, frequency next to track how many times each value appears before and after the current index. Before and after each index. do want me to make like a break grab this, break next this. Um, I do collections. Oh, collection. Wait, it's not. Wait, where's the lowercase one? Okay. Wait, this is not the one that I want. What is going on? Wait, what? Hmm. Okay, all right. Let me just use the normal one. Okay. For for each index, let's do the left. Let's do the left first. Okay, so it's left, right, and then we do right to left. Okay. I in range, and then um, what we can do here actually is frequency prev index. mm, okay, so each index. But okay, so the previous, so at each index, we're gonna find the number of elements that we had before. Oh my gosh, okay. But each index, I want the number, I want the frequency count before that index. We have index from 0 to n. 0, it will be just be 0. And then the index 1, okay. Index 1 will be equal to collections, default dict, and yeah, and then frequency spread index 1 will be equal to that one, index nums index. I feel like this is not right, dude. Okay, let me try. Frequency 1, uh, index num index 0 plus equals 1. And then we can go from 2 to n, and then frequency preg index I is equal to frequency preg index I plus 1. I mean, we have to create a new dictionary every time, right? So is equal to collection dict frequency preg index I minus I index. Hmm. Okay, this index nums index I minus 1, it's equal to frequency preg index I minus 1, index nums index I minus 1 plus 1. Oops, plus 1. Okay. So the frequency index, where am I at the moment? It's going to be I index the number that I want to count. It's the previous one. I want to count the number of this prev is equal to the frequency prev at the previous index. Index is number that I want plus 1. Okay. Now I have all the elements from the left side. Now we're on the right side. So click into next. -1. Oops. Oh my gosh, dude. Wait, -1. Now we're going to -1. That's plus 1. Do the same thing here. Now we're going to do the opposite. So from -1, -1, -1. So element is going to be the last element, but we want F. We need 2, but we need to change this one too. This is not -1. This is index n -1 -2 actually. Then n -2 is equal to 1. Yep. Oh, n is -1 and n -2 is here. We count the right side, and now we want to start right here. So that's 3. What is the length of this? At least 3. Okay, good. Okay. Now we have all the counts. Oops, this is next. Really? Next. 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 Next, make sure I have everything right. Okay. 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 Now we're gonna count. Now we can make this res plus equals frequency prev index j index. So target is equal to nums index j 2. We don't need this. We don't need this. Target is equal to this index target times frequency next index j index target. Definitely missed something, but we'll see. Blah, blah, blah. Give it a quick run. Okay, -1. Oh, wait. Oh, what? Oh, I'm a straight. Wait. Oh, okay. I was like, what kind of loop is this one? Okay. Oh, oops. Oops. Yeah. Oh, there you go. Okay. Key error 0. Oof, okay. 0. Oh, 1. Because we don't want to. The last element won't have anything, so there you go. Oof, okay. I want to make sure that the frequency pref, right, frequency pref and max are matching. See, see. Okay, let's see if this makes sense. So on my end, probably better to do separate, right? Let's see. Okay, so this is the pref. And index 0 is not right. Oh, wait. Oh, index 1, sorry. And index 1, we have on the left, we have 1, 0, and 0, 1. For index 2, 0, 1, 2, we have on the left, we have 0, 1, 2, we have 1, 1, 1, 0. Oh, oh, I see now. So what we have to do here is not this. It's frequency pref index I minus 1 dot copy, right? I think so. Now this is next. Because we want to grab everything that we had before. Let's see. Otherwise, I would just update the element that I'm in right now. Oof. Uh, the frequency next +1. Oh my gosh. Again, this. See. Ah, yeah. I knew this would happen. Okay. So let me go back to what I had before and let's take a look at the solution. I think I'm next gonna grab this. Uh, let's see where we can go from here. Was not obvious. Okay, let's see the solution. Okay. Oh, we update as we go. Oh my gosh, dude. At the first index, the counter is just the whole thing. Oh my God. Like when we start here at the first index, where's the count of elements to the right? It's just the whole thing, right? The count of the whole thing. I mean, minus itself, yeah. Uh, oh, that's why yeah, that's why, yeah. There's a count like the count of elements to the right of this thing, just the count of everything minus itself. And then we could just, okay, just keep deleting number that I'm currently in. Oh my gosh, dude. That was a good catch. Uh, oh my gosh. So thread count now is equal to collection dot default direct and integer. The next count is equal to collections dot counter, and then we can do nums. And then as we go here, uh, next count index nums index I of j minus oops minus equals 1. We don't need this. Now we can get the count. So yep. Uh, so on the left side, at the first element, we don't have anything, right? So target is equal to nums, oops, nums index j times 2, and then rest plus equals prev count next target times x count next target, and then we want to move to the next one. I need to add the current element to the prep count. Index nums, oh my god, nums xi j equals 1. Okay, let's see. Oh my gosh, wait. Uh, 2, oh, 6 here. Okay. So next minus, oh my god. Dude, this autocomplete that I have right now is super weird. I need to change my autocomplete here for Python. Okay, here, submit. Oh, I was so close. Like this counter part right here. Oh, I might. I don't think I would be able to figure this out, but I was so close. Oh my gosh. Okay, I think that's all I have. Thank you guys for watching, and I'll see y'all next time.